We need to prove that the midpoints of the sides of a quadrilateral whose vertices are provided to us forms the vertices of a parallelogram. Let us begin. Let's say we have a quadrilateral A, B, C, D. Let's name it A, B, C, and D. The coordinates of the vertices of this quadrilateral are given to us. So A has the coordinates -4, 2. B has the coordinates 2, 6. C will consider having coordinates 8, 5, and D having the coordinates 9, -7. Now let's consider the midpoints of each of the sides of the quadrilateral. We'll start with AB. So we're going to name it D. BC, the midpoint is going to be at E. The midpoint of side CD is going to be at F, and midpoint of DA, let it be at G. Let's join each of the points to form another quadrilateral. So we have D, E, F, G. So our goal will be to show that the quadrilaterals formed by joining points D, E, F, G, which are the midpoints of the quadrilateral ABCD, is going to form a parallelogram. Now, in order to show that D, E, F, G is a parallelogram, it is sufficient to show that two of the sides are parallel to each other and they are also equal in length. So what we'll do first, we'll need to find out the coordinates of D, E, F, G. Now that's a very simple problem. We'll start with D. So D is the midpoint of side AB of the quadrilateral ABCD. So that means we can easily find out its coordinates because the coordinates of the endpoints, which are A and B, that's given to us. We can use the midpoint formula. All we have to do is sum of the x coordinates, so that's -4 added to 2 divided by 2. To find out the y coordinate, we're going to sum up the y coordinates and then divide it by 2. So that means we now have -1, 4. So that's going to be the midpoint of side AB of the quadrilateral. Similarly, we can find out the coordinates of point E, F, and G using the similar method. So coordinates of E is going to be 5, 11 over 2. Coordinates of E are going to be 5, 11 over 2. Coordinates of F are going to be 17 over 2, -1. And coordinates of point G, that's going to be 5 over 2, -5 over 2. So let's redraw the quadrilateral DEFG with the new coordinates. We will show that two of the sides are parallel as well as equal. So let's begin with the side DE. First, let's try to find out the length of side D by using the distance formula. So we'll take the square root. Underneath the square root, we need is the difference of the x coordinate. So we'll do E minus D. We'll start with the x coordinate of E, and from it subtract the x coordinate of D. So that's -1. So we're going to get +1. So 5 plus 1, we're going to square this value and then add it to the difference of the y coordinate, since we started out with E. So our y coordinate of E, that's 11 over 2. From it, we are going to subtract 4. And then square this value as here as well. And when we compute this value, we're going to get the length of side DE. And that's going to be equals to square root of 153 over 2. Fine. Now we will calculate the value of the other side GF. So GF is going to be equals to square root of, so let's take the difference of the x coordinates. We have 17 over 2 minus 5 over 2 whole squared, added to, we have -1 plus 5 over 2 whole squared. When you compute this value, this also comes out to be square root of 153 over 2. Fine. So here we have obtained that the length of side DE, so that's equals to the length of side GF. Now let's calculate the slope of the side DE. So that will be equals to calculate the slope, what we do, we'll have to take a ratio. In the numerator, we'll have the difference of the y coordinates. So let's do 11 over 2 minus 4. And in the denominator, we'll do the difference of the x coordinates. So that's 5 minus -1. So 11 over 2 minus 4, that's going to be 3 over 2. And we have 5 minus -1, so that's going to be 6. And this is going to give us a value 3 over 12, or simply 1 over 4. Next, what we'll do, we'll try to find out the slope of the side GF. In the numerator, we will have the difference of the y coordinate. So let's do -1 minus of -5 over 2. And in the denominator, we have 17 over 2 minus 5 over 2. So 5, this is simply 5 over 2 minus 1. So that's going to give us a value 3 over 2 in the numerator. And in the denominator, we're going to have 6. So this is also giving us a value equals to 1 over 4. Now clearly, slope of the line segment, or we can say slope of side D, is exactly equals to the slope of side GF. And we know the property, that means if the slope of two lines are equal, that means D's are parallel to each other. This simply means that DE must be parallel to GF. So here we have got two conditions. The first condition being the two sides of the quadrilateral DEFG, DE and GF, they are equal to each other, and also they are parallel to each other. So this tells us that DEFG must be a parallelogram. Therefore, DEFG is a parallelogram. And how do we form this parallelogram? We form this parallelogram by joining the midpoints of the quadrilateral ABCD, and the coordinates of A, B, C, and D were provided to us.